Okay, ladies and gentlemen, I suppose we can start. First of all, good afternoon to everybody. My name is Alexander Svezhentsev. I am the chair of the jury, and I would like to start our meeting concerning PhD defense of Mr. Fedor Євтушенка. Now I would like to address to the foreign participants. I'm sorry for inconvenience because some part of procedure will be in Ukrainian language. However, the presentation and discussion will be in English. Шановні колеги, починаємо засідання разової спеціалізованої вченої ради Інституту радіофізики та електроніки імені Олександра Яковлевича Усикова НАН України з правом прийняття до розгляду та проведення захисту дисертації Євтушенка Федора Олександровича на здобуття ступеня доктора філософії з галузі знань 10 природничі науки за спеціальністю 104 фізика та астрономія. Спеціалізовану вчену раду утворено наказом Інституту радіофізики та електроніки імені Олександра Яковлевича Усикова НАН України номер 30 від 22.12.23 року в такому складі. Голова ради, доктор фізико-математичних наук, старший науковий співробітник відділу теорії дифракції і дифракційної електроніки Інституту радіофізики та електроніки імені Олександра Яковлевича Усикова НАН України Свеженцев Олександр Євгенович, це я. Члени ради, рецензенти, доктор фізико-математичних наук, старший науковий співробітник, завідувач лабораторії обчислювальної електродинаміки відділу теорії дифракції та дифракційної електроніки Інституту радіофізики та електроніки імені Олександра Яковлевича Усикова НАН України Стешенко Сергій Олександрович.
Добрий день, шановні учасники захисту. Федір,
Так.
чуєте мене?
Так, чую.
Чуємо, ми вже в роботі. А також кандидат
Федір,
фізико-математичних
прохання вимкнути презентацію поки що.
Добре, добре.
А також кандидат фізико-математичних наук, старший науковий співробітник лабораторії математичної фізики відділу статистичної радіофізики Інституту радіофізики та електроніки імені Олександра Яковлевича Усикова НАН України Сіренко Константин Юрійович. Опоненти. Доктор фізико-математичних наук, професор кафедри електронної інженерії Інституту телекомунікацій, радіоелектроніки та електронної техніки Національного університету Львівська політехніка Фітьо Володимир Михайлович та кандидат фізико-математичних наук, доцент кафедри надвисоких частот Харківського національного університету імені Василя Назаровича Каразіна Каліберда Мстислав Євгенович. Усі члени ради присутні. Засідання є правоможним. Порядок денний. Захист дисертації Євтушенка Федора Олександровича на здобуття ступеня доктора філософії з галузі знань 10 природничі науки за спеціальністю 104 фізика та астрономія. Тема дисертації. Resonance scattering and absorption of electromagnetic waves by infinite gratings of graphene strips on the electric substrate. Резонансне розсіяння та поглинання електромагнитних хвиль нескінченними решітками з графенових стрічок на диелектричних підкладках. Наукові керівники, кандидат технічних наук, старший дослідник, старший науковий співробітник лабораторії мікро- і нанооптики відділу квазіоптики Інституту радіофізики та електроніки імені Олександра Яковлевича Усикова НАН України Духопельников Сергій Володимирович та кандидат фізико-математичних наук, старший науковий співробітник відділу вакуумної електроніки Інституту радіофізики та електроніки імені Олександра Яковлевича Усикова НАН України Ілієнко Константин Володимирович. Відомості про здобувача. Євтушенка Федір Олександрович, 1993 року народження, громадянин України. У 2019 році закінчив з відзнакою Харківський Національний університет радіоелектроніки і здобув кваліфікацію ступінь вищої освіти магістр, спеціальність метрологія та інформаційно-вимірювальна техніка, освітня програма фотоніка та оптоінформатика. З 1.11.2019 по 31.10.2023 року навчався в аспірантурі Інституту радіофізики та електроніки імені Олександра Яковлевича Усикова НАН України. Працює науковим співробітником лабораторії мікро- і нанооптики, відділу квазіоптики Інституту радіофізики та електроніки імені Олександра Яковлевича Усикова НАН України. Здобувачем подано до спецради всі необхідні документи згідно діючого законодавства, а саме дисертація, академічна довідка про виконання освітньо-наукової програми, висновки наукових керівників, висновок про наукову новизну, теоретичне та практичне значення результатів дисертації, копії наукових публікацій, в яких висвітлено наукові результати дисертації. За погодженням зі здобувачем захист дисертації відбуватиметься англійською мовою. Окей.
Дякую.
Федір, the floor is given to the candidate or applicant to present the main points of the dissertation. Федір Олександрович, you have up to 20 minutes. Please start.
Thank you. Доброго дня. Hello to everyone and the jury member. The topic of my dissertation is resonance scattering and absorption of electromagnetic wave by infinite gradient of reference strip on the electric substrate. A total of 5 articles and 11 conference papers were published on the topic of dissertation. All papers are indexed in Scopus. This slide shows the research program and project in which I participated. Among them are both planned and competitive. Part of the work was implemented within the project of Nature Research Foundation and the competitive project of the National Academy of Science. The object and the subject of the study are presented on this slide. The goal of this work is, first, the study of resonance effect in the H&E polarized electromagnetic wave scattering and absorption by infinite gradient of graphene strip when on the electric substrate. Such a metasurface is expected to behave as a composite periodic open resonance. Its high-frequency selectivity follows from the existence of 3 types of nature modes: low Q-slap modes and ultra-high Q-lattice modes, which exist in either polarization, provided that the substrate is present, and moderate Q-plasmon modes of graphene strip that appear only in the H polarization. Second, another important goal is to study the threshold condition for the H and E polarized laser modes of infinite flat gradient of graphene strip when on a green material substrate. Here, special attention is paid to the tunability of plasmon modes and ultra-high Q-lattice mode with aid of graphene's chemical potential. To achieve those goals, the following tasks are considered: derivation of the matrix equation for scattering and absorption wave by graphene strip gradient on the substrate in the case of the E and H polarization, writing and testing codes, and validating them by comparison with the result of other convergence numerical methods when available. Study of the error behavior dependent on the matrix truncation order to confirm convergence. Use of developed codes for the analysis of the scattering and absorption characteristic of the considered graphene strip metasurfaces, especially their tunability with graphene's chemical potential. Derivation of approximate formulas for the frequency and Q factors of the plasmon, lattice, and dielectric substrate modes. Adapting this derived equation and codes to the case of a substrate made of the gain material. Combine those equations with iterative search of roots of determinable equations. Systematic full wave analysis of the threshold condition for the modes of graphene strip gradient on the gain material substrate in the case of E and H polarization. This slide shows the cross-section geometry of infinite flat graphene strip gradient when on the electric substrate, illuminated by the plane H or E polarized wave in the case of scattering problem. In the case of the eigenvalue problem, the theoretical study of the threshold condition for H and E polarized laser radiation modes was carried out. In the laser problem, the substrate materials was assumed to have a gain. I'm partly aware of the rich history of research in Kharkiv on the study of wave scattering problem by grating included strip grating. It is important to note here that those studies, which began in 1963, were devoted exclusively to grating with perfectly conductive strips, where the innovation of Riemann-Gilbert method by researchers such as Agranovich, Marchenko, and Shestopalov play a key role. Tretьякov considered such a grating on a dielectric substrate in 1963, but did not publish any numerical results. For such a grating on a substrate, there another figure calculated by Rook in 1985 in the book Resonance Wave Scattering Diffraction Grating, but without details. On the other hand, for the grating of PC strips on a substrate, there are about 10 very detailed articles by Professor Medina from Seville, which include many numerical results. All of them were obtained using the method of analytical realization with projection on Chebyshev polynomials, so they're accurate and cannot be used as a reference. In contrast to previous studies, my research focused on graphene strip laying on a substrate. Such a strip are modeled using more complex boundary conditions than those for the PC strips. Therefore, in H polarization, we had to modify RHP method, for example, to adapt it to the new boundary condition. In the case of E polarization, the RHP method is not applicable, so we use the inverse Fourier transform method. Both of those methods were first published by Zinenko in 1998. It should also be noted that the resonance and nature modes in such a structure haven't been studied much today. This is why special attention is paid to this aspect, since it's poorly understood and has significant potential of understanding the properties of those structures. My work was carried out in the laboratory of micro and nano optics, so I focus on modeling the graphene grating not only as scatter, which is traditional, but also as a laser open resonance. This opens the way for the use of graphene strips on the substrate in new context, which can have significant impact on the development of laser technology. We were motivated by several articles that use similar grating of graphene strips or other highly conductive materials on the substrate. We saw that we could model wave scattering by such grating and investigate some phenomena that haven't been studied yet. Those phenomena are discussed in more details below. This slide shows an example of the use of graphene strip grating in a tunable mid-infrared biosensor. The link to this article is below. It is important to note the presence of plasmon resonance, which makes such a sensor work. The tuning occurs due to the change in the DC electric field. That is the chemical potential of graphene. Here is an article in which a grating of flat metal, in this case silver, strips land on a semiconductor substrate while being pumped generate laser radiation in the plasmonic mode that can be supported by the silver strip. That gives us idea to investigate the threshold condition for the H and E polarized modes of laser emission from an infinite flat grating of graphene strip layer on a substrate of gain material. Since graphene is the newest material, here a little bit about graphene and its application. Graphene is planar hexagonal structure layer of carbon atom. It's two-dimensional version of graphite and zero band gap semiconductor with tunable conductivity. It supports surface plasmon wave at target frequency that create plasmon mode on the patterned graphene samples. Ultra-thin conducting material promising for many applications. Targets infrared devices, light-emitted devices, photovoltaic devices, photodetectors, and optical limits. The surface of conductivity of graphene can be determined from Kubo formulas of quantum theory and expressed by those formulas, which we have taken from this article below. Plot of graphene impedance versus the frequency. The impedance the impedance is inversely to the conductivity of graphene. Here we see a linear dependence of the imaginary part of the impedance on frequency. The real part is relatively small and almost constant. On this slide, we see the boundary conditions for the electromagnetic field in the presence of graphene, which can be used in the electromagnetic modeling and form of resistive condition. For Z zero,
Bad connection. Fedor, I cannot hear you.
Slide 12.
Can we use
Better
hear
to
me now?
This connection was lost.
Can you hear?
Yeah, now, yes, I hear you.
When I disappear, 12?
Just here.
What? I hear
Yes. Repeat slide 12.
12. Okay. On this slide, we see the boundary condition for the electromagnetic field in the presence of graphene. Can you hear me?
Yes.
It's yes, okay. Which can be used in the electromagnetic modeling and which are in the form of a resistive condition. If Z is zero, then those conditions turn into condition for perfect conductor. Plane wave scattering boundary value problem. To provide a unique solution, the following four conditions must be satisfied. For K-series field representation, in the case of scattering E and H polarized plane wave by a graphene strip grating on the surface of the electric substrate, the complex conductivity of graphene is modeled using Kubo formulas based on quantum theory. This conductivity is finite, which transforms the boundary condition to the resistive condition. For the H polarization, we use the analytical semi-inverse based on the solution of RHP method. This approach is modification of the analytical realization for the case of perfectly conductive strips, which was performed in the 1960s by Tretьяков and other researchers. In the case of e-polarization, after reducing the problem to modify DC, the RHP method cannot be used. Therefore, we perform the inverse discrete Fourier transform for regularization. This approach also leads to the Fringold matrix equation of the second kind for the Bouquet harmonic amplitudes, which ensures the convergence of our code. The equation of type 16 was obtained by Zinenko in 1998, but the eigenmode analysis wasn't performed before. Based on those above works, I investigate the electrodynamic characteristic of graphene strips grating on the substrate. The same for e-polarization. The error in the L2 norm of the solution of matrix equation truncated to finite order n is defined as shown in this formula. Due to the Fringold nature, the error tends to zero as n goes to infinity. The panels show this norm as a function of the truncation number n. For the grating parameters as indicated in this instance. On the right side are two plots comparing the result of the MAR RHP based on this formula, solid curves on these plots. With the result of other work computed using another convergence algorithm, MAR Galerkin, in the work of Francisco Medina, dashed curves on these plots. On this slide, one can see the resonance that we were able to study for graphene strip, and the graphene parameters that we use are shown at the bottom. You can also see near field for lattice mode H polarization, E polarization, substrate mode, plasmonic mode that exist due to the presence of graphene strip. In the case of graphene strip grating, we found electromagnetically induced transparency that you can see on this slide. The regime of transparency appears if the frequency of plasma modes is tuned to the frequency of the lattice mode by the chemical potential. Here, the resonance of medium Q factor P1 is optically coupled to the resonance of the ultra-high Q factor L1. In electromagnetic induced transparency, both reflection and absorption decrease. This happens because the electric field of the lattice mode has deep minima on the lattice strips. In the case of E polarization, this effect does not appear because there are no plasma modes. To make the EIT better visible, I put image of reflection relief on separate slide. We can see that the plasma mode is perturbed by the lattice mode. As a result, the transparency mode is observed. In our opinion, this effect is the most interesting new result in this part of our research. Therefore, we formulate the laser equivalent problem. The task is to find such real valued eigenpairs, chi gamma, that generate non-zero electromagnetic field function, or modes, which satisfy the Source-Maxwell equation with exact boundary condition at all materials boundaries, H condition at their edges, and Sommerfeld-Arcelor-Muller radiation condition at infinity. Here, K is the mode wave number, gamma is the threshold value of the gain index of the material in the active region. Alpha is the reflective index of the active region, it's known. Below are basic equations for deriving the determinant equation for the eigenvalue problem, which are similar to those for the scattering problem. Therefore, in order not to repeat myself, I will quickly show them. Boundary value problem, okay, series field representation. This slide shows the basic equation for deriving the determinant equation in the case of H polarization. The eigenvalue are pairs of real number, frequency, and gain index, specific to H mode. The same as on previous slide, only for E polarization. This and the next slide show the result of theoretical study of the eigenvalue problem for the H and E polarized modes of infinite flat grating of graphene strip on the electric factor, which is an active material, it has gain. The results show that the value of the laser emission frequency and gain and threshold can be controlled by manipulating the graphene parameters. Color maps of the laser determinant for even, for odd laser modes. Truncated metric truncated number equal 50. The parameters of grating, substrate, and graphene can be seen on the left. The minima on this maps correspond to the eigenvalue of the left, which we will call modes for short. The selected parameters move the eigenfrequencies of the mode of the modes for all types to target range on H map. In the frequency range from 0 to 10 terahertz. There are more than 10 modes with quite different threshold gamma, from about 1 to 10 powered minus 3. More precise values are presented in this table. We use this method to get them. Q factor is calculated by this formula. As we can see, the one very high threshold substrate mode at about 2.2 THz, which is zero slab mode, and two other on H map about 5 and 9.5 THz, which are weakly perturbed by the presence of strips and have a very large radiation losses. For the H map has a sequence of modes that have an order of magnitude or more lower threshold and follow the hyperbola. The eigenvalues correspond to the placement modes of the graphene strips. In addition, each map has two very low threshold minima at 4.16 and 7.7 THz, which correspond to the latest mode of the entire grating as periodic open resonator. The frequency are shifted to the red side from the first order of relay anomaly, which is located at 4.88 THz. The near fields shown correspond to those modes. Note that the field of latest modes are completely different from those for plasmonic modes. They form a standing wave along the entire gradient with a number of hot spots for a period twice the relay anomaly index. In the case of e-polarization, there are no plasmonic modes, but the latest modes with lower threshold are clearly visible. In this part of the work, the most remarkable thing is that the latest mode has the lowest threshold of emission, while the plasmonic mode shows the best tunability in the frequency. This is due to the change in the DC electric field, that is the chemical potential of graphene. And conclusion. We have considered the H&E polarized plane wave scattering by infinite grating of graphene strip on the electric substrate. Our treatment is based on the analytical inversion of the problem singular part with the aid of modified RHP technique and NTTF solution, respectively, and yield the Friedel second kind matrix equation. Convergence of the resulting numerical algorithms is guaranteed and hasn't been demonstrated. We have validated our code with the result of other work computed using another converged algorithm. Using this extremely fast and reliable numerical code, we have analyzed interplay of the resonance in the target's plane wave, scattering and absorption. Thanks to the tunability of the plasma modes with the aid of graphene's chemical potential controlled with DC base, the metasurface reflectivity can be manipulated in wide range. We have shown for the first time that the gradient tunability is completely lost at the region of the electromagnetic induced transparency, used by the existence of the high Q lattice mode resonance. This effect should be taken into account when designing the terahertz infrared circuit components. We have also considered for the first time that the threshold condition for the H&E polarized lasing modes of infinite flat grating of graphene strip land on gain material substrate. We have reduced the lab eigenvalues associated with lasing modes of the considered plasmonic nanolaser to the determinal equation generated by the Friedel second kind matrix operators. The lower threshold are found for the latest mode, while the best tunability is demonstrated by the placement modes. Besides, we found the substrate modes which have very high thresholds. Thank you for your attention. I'm ready for comments and questions.
Thank you, Fedor, for your presentation. Please, questions. Yes.
Can I ask a question? Сергій Стешенко.
Можна запитання?
А мене,
Yes.
мабуть, не чуть.
Yes.
Значить, читаючи дисертацію...
Англійською мовою.
Ні, не англійською, українською.
Окей,
Я
українською.
не хочу створити погане враження про
Окей.
себе. Ось. В мене таке питання. Читаючи дисертацію, я зауважив, що в одному з випадків, коли число тих зв'язаних хвиль, умовно скажемо, було 50, там дуже похибка зменшувалася на 3 порядки, на кілька порядків. І це питання, не зрозуміло, чому саме так, саме про, близько 50. От я хотів би якісь додаткові пояснення на цей рахунок. Чому все-таки при 50 так зменшується похибка на кілька порядків результатів обчислення?
Yeah, I understand the question. One second. The error. Why error change?
Тут я цього не бачу.
In dissertation we have...
число. Так, тут теж є такі осциляції, так? Точності.
In dissertation we have more results about error and to be honest, I don't study this question in my work more with more detail. It's interesting why it's happening, but maybe no, I can show this in this because it's not appear about this question.
Ну, тут також є десь при 100, так, є зменшення.
Why this decrease?
Зменшення похибки обчислень, та, така сама історія тут. Тому що я такі дослідження також свій час проводив, але для звичайних граток методом зв'язаних хвиль, так похибка монотонно зменшувалася, якщо це були дієлектичні гратки, так? Ось.
Yes,
Хоча осциляції були, але похибка монотонно зменшувалася. Тільки от для металічних граток, та, коли виникав поверхневий плазмонний резонанс, там дуже такі цікаві результати виходили, коли похибка скачкоподібно могла мінятися. І довго виходила, ну, скажімо, на вже рівень, коли результати не мінялися із збільшенням кількості зв'язаних хвиль. Ну, це перше питання, ясно. І в мене друге таке питання. Це вже останні слайди, куди там у нас добротність 10 в 10 степені, так? Ну, це надзвичайно дуже висока добротність. І в мене виникає питання, що це не проводило, щоб замітити ту добротність, так? Це ж треба з дуже малим кроком обчислення робити, так? От. І чи це не проводило якогось кардинального збільшення часу обчислень, ну, щоб і точність, і кількість розрядів обчислень повинна бути відповідна, щоб можна було зауважити таку високу добротність. Це ж можна було проскочити пік для обчислення.
Yes, I understand question. Yeah, it's precise. No, we get this result due to this method which we use in our work, and I mentioned it in dissertation, and we don't have any problem with time of calculation and other that you mentioned. And if someone want to more details about this method, in our dissertation we have 2 articles in reference which explain this in more details. That's the second question. First question, I can say, if I right understand, I can open again the slide.
Дякую. Ну, в мене поки що все.
Okay, who else wants
If I
last question?
okay.
Are there any questions?
Can I ask a question?
Yeah, please.
It's Сергій Стешенко.
Yeah.
I listened to your preliminary presentation of your thesis, and I had a comment on your statement concerning the influence of the dielectric substrate thickness on the convergence of the algorithm, because your plots do not illustrate it. Did you figure out the issue, and does this influence really exist, and if yes, how can you explain it?
About density, yes, about density, yes?
No,
Yes.
not density. I mean the thickness of the
Thickness.
of the
Yeah,
dielectric
yeah.
substrate. Do you have this influence on the convergence or not?
No, it's it's some confusion maybe in my dissertation. We investigate, but it's not so much have influence, and that why maybe you can see. But we mentioned that it's maybe not right. We can rephrase maybe this point.
Did you correct it in your description of
Yes.
your results? Okay, thank you.
Yes. Yes.
Okay. Are there any questions?
May I ask a small question?
Yes, please.
Yeah.
Thank you.
Konstantin Surenko. I have a small question, Fedor. How long does it typically take for a single run, to run a single computation to catch such a high fine resonance with such a high Q factor? Is it like minutes or hours or seconds?
It's minutes, yeah. Thank you. It's no some. It depends what range of parameters. No, how. I don't know. No, it's first of all it's minutes and maybe some 30 minutes or more. If no, it depends. Depends on how many how wide range. How no, it's depends.
Mm-hmm.
But
Thank you.
this result was about 45-30 minutes, something good.
Okay, thanks. Fedor, I have a question to you.
Yeah.
In laser problem,
Mhm.
how many parameters you should
So-
search? How many parameters are unknown in your laser problem?
It's two parameters. It's frequency and threshold. Okay. We search for 1 second. As I mentioned when I presented this slide, two parameters, K and K.
Mhm.
Analog.
And what is the connection between gamma and permittivity?
Gamma and permittivity.
Yeah. I see formula. Yes, in this slide, you see in the middle, on the left, in the middle, I see formula. It would be nice if you give exact expression gamma via permittivity.
Permittivity.
Permittivity, dielectric.
Yeah. No, this for alpha, it's index,
left.
reflective index.
Please go left. I found this formula. I found this formula. Yes, this is formula. I asked it. What is connection between gamma and permittivity? Yeah. Okay, but I still have question. Which method did you use to find a solution of dispersion equation?
We use this residual inverse iteration technique. It's analog to the gradient method. The advantage of this method that it finds the eigenvector together with eigenvalue. That's why as I mentioned, in our dissertation, we have some reference to some papers where this method in more details.
Okay, but as I understand, the gamma is the smaller the better. Yeah, if you find the smaller gamma, it will be better solution or not?
Yes, we have two main points in laser problem. If we want easy to emission, this gamma is too important because it's this parameter give us this threshold gain, which easy to have to explain it.
As can I see, the Q factor is a bigger Q factor, which
bigger Q factor, yes, bigger Q factor if smaller.
And for the laser problem, the Q factor, the bigger the better, eh?
Please again.
You are interested to find solution in which the Q factor will be the bigger, yeah?
Yes.
Okay. Okay, thank you very much. Who else wants to ask something? Okay, no questions. Let's move to the discussion of the thesis. The floor is given to the external reviewer, Fityo Volodymyr Mikhailovich. Please start.
Шановний голово, шановні члени спеціалізованої вченої ради, я хочу оголосити свій відгук офіційного опонента на дисертацію Євтушенка Федора Олександровича. Ну, на тему ми всі знаємо, так? Ось, тут чим важлива ця робота? Тому що, скажімо, градки, металеві градки на діелектричній підкладці, діелектричні градки на металевій градці, ну і всякого типу градки, та, вже дуже широко досліджувані. Вони знаходять практичне застосування. Один з таких блискучих застосувань градок – це є градки спектральних приладів. Останнім часом досліджувалися різноманітні градки для сенсорів, так, вимірювання показника заломлення радієнта газів. Дуже багато всяких публікацій. З появою, розроблений відповідний математичний апарат, і при цьому я повинен зауважити, що велику роль відіграв в цьому Інститут фізики НАН, Інститут радіофізики та електроніки НАН України, де відбувається захист дисертації. З появою графену, так, а він, як виявилось, у нього є унікальні властивості, і його характеристиками можна керувати, появились нові можливості створення періодичних структур, які мають нові властивості, так, які, як раніше, скажімо, в інших градках не спостерігалося. Причому ті характеристики ми можемо міняти, міняючи хімічний потенціал графену. І тому ця робота Федора Євтушенка є дуже важливою і актуальною. Тому що в цій роботі створюються нові знання, які мають як і теоретичне значення, так і практичне значення для створення нових приладів. Ось. Тут треба також відзначити, що великою мірою наукові результати дисертаційної роботи отримані в результаті проведення досліджень в рамках наукових програм, проєктів і грантів. Ну, тут я не буду перечисляти. Там на початку дисертації Федір Олександрович, він про це нам розказав. Також були міжнародні гранти, де він також приймав активну участь. Ось. Також тут треба відзначити, що дослідження частково підтримувалися товариством ІМ.О.Я. Antennas and Propagation, аспірантська стипендія за проєкт резонансу розсіяння та поглинання тегерцових хвиль нескінченними градками графенових смуг на діелектричній підкладці. Аналітичний регуляторний аналіз. Це 2021 року. Тобто, здобувач приймав саму активнішу участь в проєктах, які виконувалися в Інституті радіофізики та електроніки. Далі. Оцей результат досліджень, як я сказав, створення нові знання. І тому можна, скажімо, ну, я по-своєму сформулював наукову новизну. І ця новизна показана переконливо з тими результатами, теоретичними результатами, а також чисельних розрахунків. Отже, встановлено існування високодобротних резонансів на хвилеводних модах градок обох поляризацій, що пов'язані з аномаліями Релея, але не існують на градках з ідеально провідних чи графенових стрічок нульової товщини, розміщених у вільному просторі. Для H-поляризації проявляються резонанси на плазмонних модах, яких немає для Є-поляризації. Так? Ну, для графенових стрічок. Так? Для гаш-поляризації плоскої хвилі при певних параметрах градки та підкладки виявлено ефект електромагнітно-індукованої прозорості, який можна отримати завдяки перелаштуванню плазмонних мод за допомогою хімічного потенціалу графену. Показано, що коли градка з графенових стрічок розміщена на посилюваній підкладці, то можлива лазерна генерація. Численний метод визначення частоти випромінювання та порогові значення показника підсилення підкладки. Показано, що найнижчі пороги генерації можливі для градкових мод кожної поляризації з непарною симетрією, причому найкращу перелаштованість виявляють плазмонні моди гаш-поляризації. Ну і тут важливий момент дисертації, наскільки ці результати є обґрунтованими. Це важливо відмітити. Отже, наукові дослідження, результати яких викладені дисертаційні роботи проводились, по крайній мірі, з 2019 року по 2023 рік. Цей висновок можна зробити на основі виходу з друку першої публікації у 2019 році. Був достатній час для отримання необхідного досвіду для наукових досліджень, детально ознайомлення з науковим досягненням в даній проблематиці та їх аналізу. З дисертації проаналізовано 120 наукових публікацій, але я думаю, що їх було суттєво більше. Планування та проведення наукових досліджень. Задача дифракції на градках з графенових стрічок на діелектричних підкладках ставилася як строга математична задача, рівняння якої формувалися строгими математичними перетвореннями рівнянь Максвелла з урахуванням точних краєвих умов. Внаслідок коректних математичних перетворень отримано матричні рівняння Фредгольма другого типу. Ці рівняння є нескінченними, але їх усічення до числа n дає збіжність до точного розв'язання з ростом n. Розв'язок матричного рівняння Фредгольма є численно стабільним при заданих параметрах градок. Генеровані частоти та пороги генерації нанолазер на основі графенових градок на підкладці з підсиленням визначали за відсутністю падаючого поля як корінь відповідно детермінантного рівняння. Результати числових експериментів, які стосуються нанолазерів, не суперечить основним положенням квантової електроніки та лазерної техніки, зокрема загальним висновком теорії лазеру розподіленим зворотнім зв'язком. Слід також відзначити, що розроблені методи аналізу дифракції в дисертаційній роботі перевірялись на типових задачах, які описані в літературних джерелах. Результати такого численного аналізу показали добре співпадіння, по крайній мірі, з графічною точністю. Результати досліджень обговорились з цілим рядом провідних науковців, що працюють у даній тематиці на науковому семінарі Інституту радіофізики та електроніки імені Усикова НАН України, керівник академік Мележик, а також доповідалися на численних міжнародних наукових конференціях. Тут я не буду їх перечитувати всі, тут вони перечислені. От як я оцінюю практичну цінність даної роботи? Практична цінність дисертаційної роботи полягає в наступному. Розроблений числовий метод є надійним науковим підґрунтям для вивчення та аналізу характеристик розсіяння і поглинання електромагнітних хвиль, ближніх та дальніх полів, а також частот та порогів самозбудження лазерних мод графенових градок, нанесених на активну підкладку. Розроблені численні методи можуть мати ефективне застосування для розроблення та проєктування розумінних пристроїв в терагерцовому діапазоні. Закономірності, що знайдені в даній дисертаційній роботі, можуть бути корисними при розробленні мікро- і нанолазерів терагерцового та інфрачервоного діапазонів, які можуть перелаштовуватися з допомогою керованої зміни хімічного потенціалу. Виявлений ефект електромагнітної індукованої прозорості, який виникає завдяки перелаштуванню плазмонних мод за допомогою хімічного потенціалу графену, можна використати для створення у терагерцовому діапазоні фільтрів нового типу, модуляторів та поглиначів. Зокрема, модулятори можуть мати частоту переключення більше 100 ГГц, завдяки тому, що час релаксації електронів графені може бути меншим 1 наносекунди. Це є надзвичайно важливим. Те, що можна високочастотні модулятори створити. Тут повнота викладення здобувачем основних матеріалів. Результати дослідження опубліковані в 16 реферованих статтях, які стосуються скопус, включаючи 5 статей в міжнародних журналах А1, А5 та 11 статей в матеріалах міжнародних конференцій. Всі ці матеріали в скопусі. Ну, тут оцінка мови. Дисертаційна робота складається з анотації, вступу, 4 розділів, висновків та рекомендацій, переліку і так далі. Викладено на 163 сторінках друкованого тексту, містить 62 рисунки та 3 таблиці. Бібліографія налічує 120 джерел. Ну, в цілому дисертаційна робота написана нормативно англійською мовою і на задовільному стилістичному рівні. Ну, це так, ну, наскільки я знаю англійську мову. Так. Застосована наукова термінологія є загальновживаною, стиль викладу результатів наукових досліджень, наукових положень, висновків та рекомендацій забезпечує адекватне сприйняття прочитаного. Результати об'ємних досліджень викладені стисло та конкретно. Дійсно, дослідження є надзвичайно об'ємні. Дуже багато. Дуже багато. Це титанічна робота для проведення таких досліджень, ну і відповідно написання дисертаційної роботи. Ну, це я так трохи відхилився. Зміст анотації ідентичний основним положенням дисертації написано з використанням сучасної наукової термінології. Оформлення дисертаційної роботи відповідає вимогам ООН України, які висуваються до робіт, поданих на здобуття наукового ступеня доктора філософії у відповідності до тимчасового порядку присудження ступеня доктора філософії, затверджений постановою Кабінету міністрів України від 6 березня 2019 року номер 167 та зі змінами згідно постанови Кабінету міністрів номер 608 від 09.06.2021. Цілому дисертаційна робота справляє на читача гарне враження своєю актуальністю, новизною, практичним значенням і показує, що автор освоїв широкий спектр теоретичних та прикладних знань, а також вміє складати комп'ютерні програми доволі високої складності і, саме головне, здатні поставити нові важливі задачі і успішно їх розв'язати. При виконанні дисертаційної роботи використати сучасні методи теоретичних досліджень. Ну і тут зауваження до дисертаційної роботи. Так? В дисертації вказано, що хімічний потенціал графену можна міняти в широких межах електростатичним полем, але в дисертації не вказано, як подавати напругу на графіку з графену. Так? Ну, дисертаційні роботи використано стандартне позначення показника заломлення ню дорівнює альфа мінус і гамма. Ну, це може так скоріше, я говорю як оптик, бо в оптиці прийняти позначення показник заломлення середовища буквою N, який для середовища поглинаючих підсилень є комплексним. Буквою Ю прийнято позначати частоту. Так. Далі. Квантові електроніці та лазерній техніці буквою гамма позначають показник підсилення. Причому інтенсивність хвилі при поширенні підсиленого середовища зростає за правилом експонента гамма Z. Ну, чи в даному випадку, ну так, гамма Z чи гамма X. Ну, тут деякі такі рисунок 3-4 низької якості. Далі, текст дисертації на рисунку 2.4а та рисунку 2.3d приблизно при N50 маємо суттєве зменшення похибки обчислення на кілька порядків. В дисертації цей ефект не пояснений. Також є цілий ряд уписок, але це через неуважність автора. Я думаю, що автор все-таки писав свої програми, так? І він мусив ті програми відобразити точні формули, точні співвідношення, бо, скажімо так, образно кажучи, желізо не терпить помилок. Помилки були, в програмі був би абсурдний результат. Що абсурдні результати? Абсурдних результатів тут я не бачу в дисертації. Так, так що це описки просто, які є в дисертації. Тут цілий ряд описок. Далі. Не пояснено, з яких міркувань випрано К дорівнює П на лямбда, тобто періоду довжини хвилі 14,1 і 100,1, а не 14 і 100. Відповідно, сторінка 62. Такий вибір ускладнював, що спрощував обчислення. Ось, ну, таке зразу і питання є. Далі. Проте наведені недоліки не приводять навіть до невеликого помилкового сприйняття змісту дисертації, не зменшують наукову новизну та практичну чинність. Тому не мають жодного впливу на остаточний висновок про дисертаційну роботу. Більшість недоліків появилися через неуважність автора дисертації. Загальні висновки. Викладені вищі думки дають можливість стверджувати, що дисертаційна робота Євтушенка Федора Олександровича є самостійно завершеним науковим дослідженням, В роботі переконливо показана наукова новизна і достовірність отриманих результатів та їх практична цінність. За актуальністю розглянутих задач, обсягом досліджень, науковим рівнем і практичною цінністю, дисертаційна робота повністю відповідає вимогам, які пред'являються до дисертації для отримання наукового ступеня доктора філософії, а її тема та зміст відповідають паспорту спеціальності 104 фізика та астрономія, 10 природничі науки. Дисертація відповідає вимогам ООН України, які висуваються до робіт, поданих на здобуття наукового ступеня доктора філософії, зокрема в пунктів 9, 10, 11, 12 тимчасового порядку присудження ступеня доктора філософії, затверджено постановою Кабінету міністрів України від 6 березня 2019 року номер 167 та зі змінами згідно постанови Кабінету міністрів номер 608 від 09.06.2021 року, а її автор Євтушенко Федор Олександрович заслуговує на присудження ступеня доктора філософії за спеціальністю 104 фізика та астрономія, 10 природничі науки. Дякую за увагу.
Thank you very much, Vladimir Mikhailovich. Fedor Alexandrovich, please respond to Vladimir Mikhailovich remarks.
Thank you for your comments and notes about why 14.1, not 14. This is because at the normal incident, any integer value of the parameters is really anomalies. That's the branch point. Thank you for your comments.
And you are satisfied with all remarks, yeah? Yes, I understand.
Дякую, я згідний. Так. Чи я задоволений, точніше.
Excuse me, Fedor, you answered to all comments, all remarks, yeah? Yes, I understand.
Yeah,
You agree that you agree with all.
Yes, of course, I agree with all comments and.
Okay, we should. And Vladimir Mikhailovich also are satisfied with all answers. Okay. Next step, the floor is given to the external reviewer, Kaliberda Mstislav Evgenovich. Please start.
Yes, thank you. Good afternoon. In the dissertation, Fedor Євтушенко study and reveals the electrodynamic properties of the infinite graphene gratings with the electric substrate. Special attention he pays to the resonance phenomena, and for this purpose he develops the method of the Riemann-Hilbert problem. As one can know, strip gratings are widely used in microwave and optical technologies. Also, they show performance for creation and improvement of devices in terahertz and infrahertz ranges. Especially taking into account appearance of new materials, such as graphene, which has thickness of one atom and, in fact, can be considered as zero thickness resistive surface. About timeliness of dissertation topic, the periodically structured strip collections of gratings are widely used in microwave and optical technologies, and therefore the topic of the dissertation is timely. Here in this periodically structured strip collections, the grating mode or lattice mode resonances can exhibit extremely high Q factors, and in their vicinity a sharply pronounced extremis of scattering characteristics are observed in the extremely narrow frequency band. However, the use of the inefficient methods, which, when computing the frequency dependencies, requires the selection of two large frequency steps, or incorrect interpretation of results, can lead to failures in real-life existing devices. This is particularly relevant to the appearance of blindness zones in phased antenna arrays and narrow transparency zones in observers. Among the variety of methods for studying the scattering of waves from strip gratings, It is not possible to single out a universal method that allows to analyze the electromagnetic characteristics of complex objects from a single perspective. This is especially true for looping systems. Purely mathematical methods distinguished by universality take into account the radiation condition at infinity in approximate way, limiting the accuracy of the obtained results to a few digits. Neglecting the edge condition, as known, hidens the existence of a unique solution. Consequently, non-physical solution may be obtained. Therefore, the timely task is the development of the methods that have the guaranteed convergence, satisfy the conditions of the uniqueness theorems, and allow obtaining results with acceptable computed time. Graphene is relatively new material with unique properties. It is strong enough, absorbs electromagnetic fields, and can support surface plasmon polariton waves and corresponding plasmon resonances at 10 Hz. At the frequencies 2 orders of the magnitude lower than the noble metals. The conductivity of graphene and therefore the properties of the entire structure containing graphene inclusions can be dynamically controlled by applying electrostatic or magnetostatic doping. This opens significant prospects for using the graphene in tunable devices. In connection with this, the choice of the purpose and tasks of the research, objects, mathematical methods, means of analyzing the electromagnetic characteristics of the gratings, determination of the general laws of electromagnetic wave scattering allows us to assert that the topic of the presented dissertation is timely, both in the fundamental and applied sense. What about the scientific novelty of the obtained results? In this work, a full wave and meshless, mathematically grounded approach is used to analyze the fundamental effects in the scattering, absorption, and radiation of electromagnetic fields by the gratings of graphene strips on a substrate. A unified approach to the study of structures based on infinite gratings of perfectly electric conducting or material graphene strips on a dielectric substrate has been developed. In the dissertation, the author obtained a number of new scientific results, and I can highlight some of them. The results of the long-term studies of the wave scattering from infinite gratings of perfectly electric conducting strips on the dielectric substrate were generalized. Solutions to the corresponding diffraction problems were formulated using the Riemann-Hilbert problem method in a form suitable for direct programming. The positions of the grating mode resonances on the frequency axis were determined, and the regularities of the variation with changes in parameters were described. Effects related to the excitation of these resonances, such as anomalous transmission and reflection, were investigated. For the first time, the Riemann-Hilbert problem method was adapted to the H-polarized plane wave scattering from the infinite graphene strip grating located on a dielectric substrate. This rigorous approach allowed for a detailed study of resonance effects in the scattering and absorption of the plane electromagnetic wave and their variations with changes in geometrical and material parameters. The physical regularities and that are important for practical applications were determined. It was found that due to the excitation of plasmon resonances on graphene strips, the structure can serve as a polarizer, allowing the transmittance of the e-polarized waves while...
Interrupting you, excuse me for interrupting you.
Yes.
We have some time limits in this defense. So I would propose for you to be more precise in your scientific evaluation. Okay?
Okay. Oh, yes, I understand. So about grading mode resonances, I said that they're important as fundamental part as well as from practical point of view. As one can know, graphene strip can support plasmon resonances in terahertz or infrahertz frequency range, and near them the growth in the absorption and scattering characteristics is observed. And in the dissertation, the physical regularities that show fundamental importance and are important for practical applications were determined. The information gathered in the research about the significant influence of chemical potential on the structures of graphene dynamically controllable through the application of electrostatic field on the characteristics of the scattered field allows to use the raising effects in implementing control function in the devices incorporated such gratings. Plasmon resonances can arise in the E polarization case and do not in the H polarization case and do not exist in the E polarization case, and the identified in the dissertation properties and regularities can enable the creation of tunable polarizers and filters based on the considered structures as a consequence. Also, effects related to the simultaneous excitation of the plasmon and grating mode resonances, such as anomalous transition and reflection, were investigated. The effect of electromagnetically induced transparency were revealed. Based on the developed mathematical model, the Fedor Євтушенка studied the threshold conditions of the modes of a laser, consisting of the infinite graphene strip grating on the electric substrate. Obtained results have undeniable practical significance for designing new terahertz and infrared micro or nano lasers, tunable lasers. He reveals three types of modes that are present: strip, plasmon modes, grating modes, and substrate and the electric substrate modes. He shows that the position of the plasmon modes can be controlled dynamically by varying the chemical potential of graphene. And the grating modes have much lower threshold gain values, but are almost insensitive to dynamic tuning of frequency and threshold. Especially, I should mention that Fedor Євтушенка obtained asymptotic expressions for the plasmon resonance frequency, and they are undoubtedly novel, as well as other obtained results regarding regularities of excitation of various types of resonances and resulting resonance effects, which I mentioned above. So I have several comments about drawbacks in the dissertation. So as other dissertations, this work is not without certain flaws. In chapter 1, the author states that non-local effects can be neglected for strip widths greater than 100 nanometers. However, he considers a strip with widths of 35 nanometers. And for example, in figure 4.7. So the next point, the parameter alpha, which corresponds to the incidence angle, is presented in the expressions for the matrix equations of the plane wave diffraction problem from the infinite graphene strip grating on the dielectric substrate. However, in chapter 4, this parameter disappears from the expressions. So please comment on this. And on pages 96 and 97, the author notes that the rate of convergence is the highest in the case of normal incidence. And the absence of the electric wire, however, this case is not presented in the dissertation. On pages 63-64, it is stated that the error decreases with an increase in the order of matrix reduction. However, in the case of wave number equals 100, some curves exhibit accelerations and do not show the noticeable decrease. And there are some inaccuracies in the work which are shown in my review. However, these points are not related to the fundamental aspects of the dissertation, not related to the results and conclusions on the work, and do not impact the positive assessments of the study. So, the dissertation of Fedor Євтушенка, Resonance Scattering and Absorption of Electromagnetic Waves by Infinite Gratings of Graphene Strips on the Electric Substrate, represents a comprehensive scientific investigation conducted at the high level. The results presented in the dissertation contribute to a new scientific direction in modern physics, especially in the field of electrodynamics of periodic graphene structures, interhertz and infrared ranges. Considering the arguments presented above, I believe that the author, Fedor Євтушенка, deserves to be awarded the degree of Doctor of Philosophy. Thank you.
Thank you very much, Dr. Kaliberda. Fedor, please answer to Slav Evgenovich.
Thank you. Yeah, I would like to respond to some of reviewers' comments, namely, first, states that the non-local effect in graphene conductivity can be neglected for the strips widths greater than 100 nanometer. However, in chapter 4, widths of 35 nanometers chosen. They estimate that the Kubo formulas are correct if the graphene size is larger than 100 nanometers was taken from the literature. However, as you can see, I prepare a slide, but I don't show this to be faster. In some articles which we found in Science, in the real life, by chance, with the width of the strip was much smaller, 30 nanometers. As we have checked, the plasmon mode frequency for 30 nanometers strip is that in this article and perfectly predicted by our results that we obtained using the Kubo formulas. Therefore, 100 nanometers is exclusively conservation restriction. And second, about there's a parameter which correspond to the plane wave incident angle and hence the phase shift between adjacent periods. However, in chapter 4, this parameter disappears from the expressions. Apparently, it's assumed that the phase shift equals 0. Why only this case is considered? Indeed, when analyzing the threshold condition for such a wave, we assume that there is no phase shift between the great adjacent periods. In the scattering, this happens at the plane wave normal incident, and then the zeroth order Fourier harmonics radiates in the normal direction as well. The justification of a choice can be seen in the experimental paper about the laser based on periodic areas of nanoparticles. The published measurements shows the normal direction of laser emission. However, it's no problem to involve this phase shift in our analysis. Thank you. I agree with all your comments and noticing incorrect.
Thank you very much. Mstislav Evgenovich, are you satisfied with the answers?
Yes, I am satisfied with the answers.
Okay. Next step, the floor is given to the internal reviewer, Dr. Sergey Alexandrovich Stishenko. Please have a floor. No. We cannot hear you.
Mutin. You are mutin.
Can you hear me now?
Okay, thanks. You switch on.
No doubt that this research is important and significant because mainly because it contains structures with such a promising material as graphene. I would not stop on its properties because they were already discussed. I would emphasize the strong mathematical background of the work, the correct formulation of boundary value problems, and the use of rigorous mathematical methods for their solution is a strong point of the work. Among the new interesting results, I would select those which are most interesting for me. Among them, the classification of resonances, some new resonances which were found, the electromagnetically controlled effect of transparency in the case of edge polarization, and the investigation of the field distributions of the modes of periodical strip gratings on dielectric substrates. The reliability of the obtained result is confirmed by comparison with known results for gratings of resistive strips. The results were published in 5 papers published in high-ranking foreign journals. I had some critical comment concerning the statement of the influence of the substrate thickness on the convergence of the algorithm, and I'm glad that it is corrected. The main part of the thesis is written in proficient English, but there are some misprints in the Ukrainian abstract. I will not stop of them because they are not very important. I believe that the thesis of Євтушенка is a completed scientific work that contains a number of new relevant and reliable results. It fully complies with all requirements, and the candidate deserves for awarding him the scientific degree of Doctor of Philosophy. That's all. Thank you for your attention.
Okay, thank you very much. Fedor Alexandrovich, please respond to Dr. Євтушенka remarks.
Yeah, yes, I agree with all comments. Yeah, thank you for all of them. Yeah, I agree.
Okay, so next step, the floor is given to the internal reviewer, Dr. Sirenko Konstantin Yuryevich. Please.
Thank you. I will not go into very fine details of my review because many similar things have already been said by previous reviewers. So I will point out only the moments which are most important from my point of view and or different from what has already been said. Well, first of all, I would like to comment that it was that the research topic was found very witty when like seemingly well-studied structure of a periodic grating find a new use and new properties of it are discovered when it's combined with graphene, which is a new material, and so for 10 years it's been intensively studied, but still there are some things to learn about it. So this is a very nice point about this dissertation, and also it's topical because the reliable algorithm developed in it allows to simulate and study those structures without access to research labs, and it is very important for Ukraine, where the infrastructure for graphene studies is nearly absent. Next, the work is well written in nice English. It's interesting to read, and I had no problems reading it. So it's logically written, starting from review of a state of the art and literature review, finding the gap in knowledge and to focus on it, and then developing a mathematical model for it, numerical resolution of the mathematical problems and application of developed algorithm and programs to research to obtain new knowledge. Another point to mention is that this work was supported with a grant from IEEE, and it was partially done in collaboration with Kyiv University and University of Rennes in France, which is also highlights its scientific importance. I will not stop on no scientific results. It's already been pointed, and the reliability of obtained result follows from the use of rigorous mathematical derivation of the problems to consider, and then and the algorithm developed on these mathematical problems have controlled precision. So, and they were also tested thoroughly, comparing with another well-respected algorithm. And the one point here is that I pointed as a drawback. It was also nice to see the comparison of developed algorithm with the precise solution for the situation where they exist. The importance of obtained results. So as the algorithm are reliable and precise, they could be used for development of new devices and optimization of existing one, or search for new, more efficient parameters. So this is, and the discovered effect of electromagnetic induced transparency and the ability to control grating properties with graphene are also very important and promising for development of new devices in terahertz range. For to obtain this new result, a number of scientific problems or tasks were set and solved, which says that Fedor has mastered the art of scientific research, and it was done on a high level, not only for local science, but high international level. And he's so next, I will not list all the problems solved, and conclude with my notes and to the dissertation. Naturally, the work of this volume has some drawbacks, but they are pretty minor and don't influence the general positive impression from it. So my first point is that the programs used for computation during this work are written in MATLAB, as far as I understand. So Fedor mentions that they work pretty fast, and computation takes minutes, an order of minutes. But I believe if these programs are written in C language, they could work much faster and could be easily parallelized. I don't know if it's parallelizable like a solution of single problem, but if it's used for optimization, when a lot of combination of parameters should be checked, and it could be done in parallel, it could be, I guess, much faster than with MATLAB code. There was some issue with weight coefficient in formula 2.39. It was the same weight coefficient was in E and H polarization, but it was mentioned that it shouldn't be so, but I believe it just a misprint or something. So the error was studied. It was never mentioned how fast it decays, like what is the order of, is it n logarithm, n or n square? It would be interesting to put not only the error curve, but like a parallel to it to compare how fast it decays, like a curve, a line of n square, n of or n log n. As I said, it was also instructive to compare the algorithm for test and for error studies, not only with themselves, but with higher precision and other algorithm, but with exact solution, of course, for the cases where exist. And the last thing on pages 65, 68, it was not clear completely if the resonances discussed there is a new result or it is a continuation of a validation of algorithm. But nevertheless, those are cosmetic notes, and the general impression of the work is very positive. It's definitely qualifies Fedor as a scientist ready for a serious scientific career, and he definitely deserves the award of a PhD degree. So this is it. Thank you.
Okay, thank you very much. Fedor, please respond to Dr. Serenka remarks.
Thank you for your all the points you mentioned. I agree with them. Last one was, yes, was a new result, and I agree with you. Perhaps the calculation wouldn't be fast in C languages. Thank you.
Okay, thanks. Are you satisfied?
Yeah, absolutely. Thank you.
Okay, thanks. Accordingly to the procedure, all members of the jury must participate in the discussion of the thesis. Please start. Who wants to tell something? But I understand that in your response, you presented all already.
I can be first if it's
Okay,
possible.
thanks.
What I like the most, it's the comprehensiveness of this work. You could restrict yourself and to consider only the case of the most interesting case of H polarization, but you are also considered E polarization, which is good. And I would say that you considered almost all classical formulation of the scattering problems for periodical strip gratings. All this makes this research consistent and comprehensive, and of course I would vote yes.
Okay, thank you very much. Who else wants to tell something? Just briefly.
Okay, may I? I got the first impression the first positive impression on this work, reading the thesis, it is well written and easy and interesting to read. And then the presentation of Fedor on this, the seminar, and today only made this positive impression stronger. So I believe this work is definitely enough to award Fedor's PhD degree. So I will support it.
Okay, thanks. And I would like to, and yes, please start, Володимир Михайлович. Please start. Yeah.
Що я хочу сказати? Я вже багато разів був, ну, і опонентом був, і експертом дисертацій, і я можу порівняти якість дисертацій, і хочу сказати, що Євтушенка Федора дисертація зроблена на дуже високому рівні. Це надзвичайно титанічна робота, щоб за такий короткий період провести такий величезний об'єм і обчислень, але перед тим, як провести тих обчислень, треба буде всьому тому розібратися, тих формулах, тих методах і так далі. І тут ще позитивно те, що не всяку роботу можна вважати такою, знаєте, революційною, ну, в якійсь певній мірі, так? Що можна робити роботи, і це не має змісту якогось. А тут ця робота спрямована для отримання позитивного результату, скажімо. І новий код, і нові ефекти відкрилися, і запропоновано, скажімо, можна зробити нові лазери, нові пристрої. Тобто в цьому відношенні робота має і теоретичне значення, і має серйозне практичне значення. Тому я вважаю, ще раз наголошую, це дійсно титанічна робота зроблена, і тому Євтушенко Федор заслуговує наукового ступеня доктора філософії по вибраній спеціальності.
Дякую, Володимир Михайлович. And but I would like to ask a scientific supervisor, Dr. Дохапельников. Do you want to tell something to audience?
Yes, thank you very much. I tried to be brief. I wrote in my supervisor conclusion, and we saw in Fedor's presentation how he received, calculated, obtained, wrote a lot of different things. And I think Fedor was an excellent PhD student, and he made excellent work. So for my opinion, Fedor has all necessary knowledge and skills to get a doctoral degree.
Okay, thank you very much.
Я ще хочу додати.
Okay, start, please. Yes.
Я ще хочу сказати, чому такі успішні результати в дисертації. Тому що все-таки інститут імені Усикова, радіофізики і електроніки, це є потужна школа. Дуже потужна школа. Я вважав давно, я вже багато праць прочитав науковців цього інституту. І зауважив, що дійсно строгий математичний підхід до проблем дифракції. І дійсно потужна школа, і Федору є кого повчитися, скажімо так. Хороші вчителі. І тому такий хороший позитивний результат. Дякую.
Дякую, дуже дякую. Who else? Maybe some foreign participants want to say something. Okay.
Олександре Євгеновичу, ви також маєте сказати декілька слів, і ще шановний опонент Каліберда теж.
Yes, okay. Мстислав Євгенович.
Yes, Karan, but the Francesco Medina want to speak.
No? Excuse me, I didn't
I can hear you.
Yes, okay.
No, I can hear.
I can hear you. It's okay. Mstislav Yevgenovich, will you tell something additionally to your response? Please tell something.
Yes, as I said in my review, that the results presented in dissertation have both fundamental and practical value. They can be used, for example, in antennas design, in filters, and so on. So the results demonstrate initial consistency. The work demonstrates initial consistency. I'm sorry. And the results presented at the conferences, a lot of papers are published. So I think that the Fedor Євтушенка deserves to be awarded the degree of Doctor of Philosophy. Thank you.
Okay, thank you very much. But I would like to tell something. But first, I would like to tell something concerning maybe some remarks. And I saw the way how, if you remember, there is a slide in which you can notice how we can change chemical potential. We can just apply voltage, yeah, apply voltage. But frankly speaking, in some paper, I meant that we should arrange a constant electrical field to change as a condensator, and we should put graphene in this construction, and in this case, the chemical potential will be changed. So I still don't know what is true, just to apply voltage or to put in some special construction. Fedor, do you know something about this?
Yes, I only can suggest this, which I mentioned it, and we don't do experimental results. No, we don't get experimental results. That's why I can say how it's exactly work. But we saw in several papers how it was there. Oh yes.
Okay, thanks. And I joined to all positive points of the discussion concerning that this work is really impressive, is very high quality scientific work, because I agree with Vladimir Mikhailovich, because this work is based on previous dissertation, from 1960s. So people did something in this direction, and only in 60 years you are able to change material, to remove metal, and to introduce graphene, and you got some new results. So I estimate your work as a very nice scientific work with a good publication, and with no doubt, for me, you deserved to have PhD degree.
Thank you.
Okay, doesn't anyone wants to speak, to tell something? I suppose no. Fedor.
Francisco Medina want.
Yes, please, Francisco Medina. Where is he?
But we can't hear.
We cannot hear. Oh, it's pity. It's pity, but he tries to tell something, yeah. But I cannot hear. I cannot hear him. So I cannot see. But microphone doesn't work. Oh, his microphone. Francisco Medina. We cannot. Excuse me. We cannot hear you, Professor Medina. We cannot hear you. No connection. No connection. Sorry. You should change something in your computer, please. Do something, because some of the members are abroad now, and we have good connection. We should listen. We should hear you. It's a pity. Maybe Nicholas Tisas wish to tell something.
Yes, hello, can you hear me?
Yes, Nicholas, we can hear you. Please.
Okay, I'm sorry if there is some noise because I am in an external space, but
Yeah.
I would like to provide some comments concerning the work of Fedir and the presentation I have just heard. First of all, I would like to say that I know very well some aspects of this work. I can also disclose that I have been a reviewer for some of the journal papers that Fedir has published some years ago. So I was very happy to go through the details of Fedir's work, and particularly regarding the mathematical aspects of his methodologies and the details of the convergent algorithms that Fedir and his supervisors have developed. I believe that these are some very strong tools for the numerical modeling of such difficult electrodynamic problems, and they serve as very good and let me say established reference solutions for more complicated problems that can be encountered in industry and in the implementation of such structures in a laboratory experiments and so on. So I have known the work of Fedir and the associated research group, I could say, for many years now, and I'm very happy that he is now concluding his work, and he presented today his work with many details, and he was able to answer conclusively all the questions that the members of the jury posed to him. So after having said these remarks of me, I would also like to say perhaps something that, if I understood correctly, was not mentioned so well by previous speakers, and that is that Fedir's work is important also for another aspect, the fact that nowadays everybody is using some readily available commercial codes to analyze such structures. For example, COMSOL, HFSS, CST, and so on. But there are many cases when these readily available solvers cannot provide good accuracy. So despite the fact that we frequently have to use such solvers, we are not always confident that such solvers can provide accurate results. And I believe that it is for this additional reason that the work of Fedir is important to analyze such structures and provide accurate solutions which can be further utilized in related applications. So I was very happy to attend this talk and to hear Fedir's presentation. And I wish all the best for his future. And I'm sure that he can accomplish many more interesting scientific achievements soon. So thank you very much for listening to me.
Thank you. Thank you.
Thank you very much. Professor Medina, are you ready to tell something?
Can you hear me now? Can you hear me now?
Yes,
Yes,
yes.
yes, we can hear you now. It's better. It's considerably better.
Great.
Yes.
But maybe the problem is that you cannot see me. No?
Yes, really, we cannot see.
Yes.
We cannot see you, but we can hear.
Let me see 1 second to change the configuration. Okay. Well, anyway, if you can hear me, it's enough. Okay, I don't know. There are some technical problems here. I can connect only the microphone or only the video. I see. Well, first of all, I would like to say that thank you to Alex Nosik that attract my attention to this presentation and to this thesis. in the past, we did some work in my group that has some similarity with this kind of work that is characteristic of the Ukrainian School of Electromagnetics. The first time that I was aware about the method of analytical regularization and other highly analytical techniques was during a conference, I think in 1991, where Professor Nosik explained this technique in the context of analysis of microstrip transmission lines, if I remember properly. And I was very impressed about this kind of work. Since that moment, I've been following as much as I have been able, because my topics of research have been changing along during the time, and I always enjoy the quality and the depth of the studies coming from Ukraine, and in particular from this research group in this topic. So I've been very impressed by the quality of the results and some data as to read in the document and the report of the thesis that the method can't get results at machine precision. That is very, very impressive. That means that probably due to this feature of the proposed technique, you can catch this extremely high quality factor resonances. And I wonder if you, this is now a question or a comment, if you think that software, commercial software based on finite elements or similar numerical approaches can also get these very narrow band spikes that you have obtained in your spectra. Another point is to ask you about some work that I have also read in the literature that is related with this work. I mean, with the study of strips of graphene periodically distributed over a dielectric slab that come from an Iranian group. I don't know if you know Amin Khabasi. This group has proposed some equivalent circuits for this kind of structures, where the parameters of the circuit are extracted from some integral equation formulation for the problem. If you are aware of this work, my question would be: do you think that this kind of models can take into account all the variety of phenomena that can be studied with your proposal, with your technique? Well, let me finish my speech saying that congratulations for the high quality of your work, and I also wish you a very lucky and very fruitful academic career. And last but not least, I'm also very impressed that taking into account the hard condition that you are living in your country now due to the Russian aggression, you still go ahead and the life is followed, and you still are able of working, developing so high quality research. This said very good things of Ukrainian people. Thank you for your work, and thank you for the nice presentation that you have prepared for us today.
Okay. Thank you, Professor Medina, for your
Thank you very much.
impressive speech. Who else want to speak, to tell something? I suppose we should close our discussion, and further I will
Maybe I summarize first.
Further. Sorry, I forgot further. Please, you have a floor for the final word. Yeah.
Thank you. I would like to express my deep gratitude to Professor Alexander Nosich and my supervisor Sergey Lyukhopennikov and Konstantin Ilyenko for the help and mentoring in this preparation of this dissertation. I would also like to thank certainly the member of my thesis jury for the participation and evaluation of my work. Your expert assessment is very important for me and for my continuation of my research work. And in the future, I plan to continue working on these laser-met problems and prepare some paper for conference, non-UMC and journal publication. Thank you very much.
Okay, Fedor, thank you very much. And далі переходимо до голосування щодо присудження Євтушенку Федору Олександровичу ступеня доктора філософії. Голосування відкрите, підняттям руки. Члени ради, хто за? Хто проти? Немає. Утримавшися? Немає. Результати голосування. За присудження Євтушенку Федору Олександровичу ступеня доктора філософії проголосували 5 членів журі. Шановні колеги, вам заздалегідь було розіслано проект рішення Ради про присудження ступеня доктору філософії Євтушенку Федору Олександровичу. Переходимо до обговорення. Чи є зауваження або коментарі щодо проєкту? Немає. Тоді оголошується рішення Ради щодо присудження здобувачу ступеня доктора філософії. На підставі результатів відкритого голосування спеціалізована вчена рада присуджує Євтушенку Федору Олександровичу ступінь доктора філософії в галузі знань 10, природничі науки, за спеціальністю 104, фізика та астрономія. Федоре Олександровичу, вітаємо вас з успішним захистом дисертації. Бажаємо успіхів у подальшій роботі. Thank you very much to everybody for participants and my best wishes to all you.
Thank you. Дякую дуже всім.
So our meeting is closed. Thank you very much. I wish all of you best. Oh, thank you very much. Thank you very much.
I had prepared this in case this didn't work.
Yes. At last,
We can